So in this short video, I just want to demonstrate how you complete your lab assignments. I want you to create a Jupyter notebook, and it's exactly that notebook that you're going to send to the TA or look out for instructions by the TA as to how you're supposed to submit your work to them. But what I do want is that Jupyter notebook with your Python code. So let's go to my desktop and I'll show you exactly what I want you to do. I'm hoping that you've created a folder in which you're going to do your work for this course. I'm right here on my desktop, and this is where I'm going to do it. I'm going to right-click and I'm going to say New Folder. I'm just going to call that folder PUBH 6852. There you go, and my work's going to live inside of that folder. Now, I've already downloaded and installed Visual Studio Code. I've downloaded and installed Python. Please remember, there are announcements on Blackboard with links to videos that show you exactly how to do this. So I'm going to open my Visual Studio Code. While Visual Studio Code is open, I'm going to click on this Explorer button at the top left that just expands this, and I can click on Open Folder and navigate to this folder that contains my work. Or what I could do is, if I have this folder available here in Finder or in your Explorer on Windows, you can simply take this folder and just drag and drop it onto a blank section here. Now it's going to say, do you want to trust these authors? I'm going to say yes. And there we go. We can see we are inside of this folder. Now, do remember, in those instructions, I show you how to set up a virtual environment. Once you've installed Python, you do not want to interfere with those Python installations. You'd rather work in a virtual environment. Now, in the videos that I have linked to you before, I show you how to set up Conda environments. But in class, we are just going to do virtual environments. You can do either of the two. So let's go for setting up the virtual environment that's a copy of one of your Python installations right into this folder. And the way that I'm going to do that is to hold down Shift, hit Command or Control, and I'm going to hit P. So on a Mac, Shift Command P. On a Windows machine or Linux machine, Shift Control P. And what I want to search for is in this bar that comes up at the top. Now, there are so many of these commands built right into Visual Studio Code, but the ones that you have recently used will pop up the top. If you haven't done so already, yours is not going to be at the top. The one that I'm looking for is Python : space create environment. So you can type that in the search bar at the top. That's the one I want. I want to create a virtual environment. So Python : space create environment. Once I do that, I have a choice. Now, I told you before in the videos, I do show you how to set up Conda, but here we don't have to do it. Let's just go to the built-in virtual environment. So I'm going to click on that. Then it's going to list all the versions of Python that I have on my system. Now 3.9, too old already. I'm going to go for 3.13.7. And now on the bottom right hand side, you can see that that is being installed. In the top left, you can see there's a brand new subfolder or subdirectory inside of this PUBH 6852. That's the virtual copy. It's looked at your Python installation in your system. It's made a copy right here. If I open that up, you can see all the subfolders there, and you will actually find Python running in this binary or bin subfolder. So I want to click outside of this. I don't want to click on VNV because these little buttons that come up there, if I hover over that first one, you'll see new file. That's how you create new files, but I don't want to create that new file inside of VNV. So I just want to make sure I'm clicking here on a blank space, and I'm going to create a new file. And let's call that file week1 labs. That'll be a good name. .ipynb. The important thing here, of course, is that file extension .ipynb. That makes it a Jupyter notebook, and indeed a Jupyter notebook opens up for us on the right hand side. Now we do want to install some packages into this version of Python, and the way that we do that, remember you only have to do this once, install extra packages inside of this virtual environment. What I'm going to do is hold down Shift Command P, once again Shift Control P for the Windows people, and what I want to search for is Python : space create terminal. For me it's going to be right at the top because I often use that. So if you don't see it, it's going to be way down this list under the P's. And so just type in the search bar there, Python : space create terminal. So I click on that, and then we can see I am inside of this virtual environment. It's very important then that you see the .venv there. Now we're going to install some stuff. So this is where we do our Python package installations using the pip command. So I'm going to say pip install. And for instance, let's install NumPy, numerical Python. The one that you really need And if you forget to do it, there is going to be a little box that pops up the first time you try to run some code, and it's going to warn you that you haven't done this. You can just click on install when you see that warning. But I'm going to do it right here, and I'm going to say ipykernel. ipykernel. Now, do note there's no comma in between these package names. So you don't have to do the NumPy now. We're certainly going to do that later in the course. The one that we do absolutely need is this ipykernel. Again, you don't need to do NumPy now. We can do that later. But the pip install ipykernel, very important. Note, no commas in between these packages that I'm importing. I'm just going to hit enter or return, and it's going to be installed. You have to wait a couple of seconds, and it's all done. So I'm just going to close my terminal. That's a little button there, and I'm ready to go. On the top right, though, we've got to tell this notebook, well, what version of Python are you using? So you have to click on Select Kernel. Now, I want a Python environment, so I'm going to select that. And there's a list of all the environments that it can use. Now, we've just created this virtual environment, .venv, with Python, a copy of Python 3.13.7 in there. It says recommended. That's the one I want to choose. And immediately you can see that's the version of Python that is now running inside of this notebook. So the first thing I want to do is just to give a nice title, and we're going to do that in a markdown cell. So I'm going to click on markdown, single hashtag and a space inside of a markdown cell. That means give me the largest font size that you have, and maybe I'll say week 1 labs, something like that. Shift enter, shift return, and there you go. It's nice, the largest font size that we have. That's absolutely brilliant. The next one, you can see I'm still doing, this is still a markdown file. Maybe I'll do something fancy with my markdown. I'm going to do greater than and just say my name, something like that. If I shift return, shift enter, you can see, well, a little bit of a gray background, a nice little gray, darker gray bar there. It's just a way to control the look of these cells, these markdown cells that give you normal text. Next up, let's choose the second largest font size as our section headers. So I'm going to do 2 hashtags, and I'm going to say question 1 because that is the way that these questions were named inside of the labs. So let's do question 1, shift return, shift enter. And now you can see it's slightly smaller font because there were 2 hashtags. You can go down to 6 hashtags. It'll be the smallest one. And I think the first question was talking about Python. Now you can research that. You can use AI. You can just research on the internet. And you can copy and paste some normal English sentences in here for question 1. But read, whatever you find. So I'm just going to say, this is a paragraph of text. So you can just copy and paste that. And remember, you can just create more and more of these markdown cells. And that is just going to create, allow you to do different paragraphs. You can put all of it inside of one markdown cell. It really doesn't matter. You're going to get to a question that wants a little bit of math. So let's assume the following. Let's assume that question 3, I'm just going to go question 3. Once again, see the 2 hashtags. And now there's uniformity for the sizes of these subsections. And that had a little bit of math in it. So at the moment, because this was a markdown cell, it'll generate another markdown cell for me. But what I want is a code cell. So I'm just going to hover in between this question 3 and the currently active cell. If I hover between the 2 of the 3, you can see I can generate some AI code. I can write some code or do another markdown. Let's do code this time. And in question 3, I think, assuming that the first question was 3 times 8, let's use AI to generate the Python code for us. How we do that is also with a hashtag, but remember this is inside of a Python cell, so that's not going to control the size of the font. That only happens in a markdown cell. Here we have a way to leave either a code comment or to write a prompt to our large language model. So I'm going to say multiply 3 and 8. And as if by magic, the code was written for me. I can just hit the tab key to accept that, or I can click on this little green button there. It changes into a tick mark. I'm just going to say, yes, I'll accept that. And now we can interrogate that code. 3 star 8, and star symbol in Python means multiplication. If I hold down shift and hit return or shift enter, I get the solution, which is 24. That's absolutely great. Let's do the next one. So again, I'm going to hover here in the middle. I'm going to select a new code cell and imagine that was adding 33 and 7 and only then dividing by 5. So the order of arithmetical operation here is important. And let's see if we can write a prompt to generate this. I'm going to say add 33 and 7 and only then divide by 5. And let's see, there's the code. I've hit the tab key to accept it. Let's interrogate this. So to use PEMDAS, we see the 33 plus 7 was added inside of a set of parentheses, and that's going to be executed first. And we see the plus symbol does addition for us. When that is done, which gives us 40, we're going to divide by 5, and we see the / is the way that Python denotes division. So let's do Shift and Enter, and we should get 8. And indeed we get 8, but we get a special version of 8, not the integer 8, but the decimal version of 8. So 8.0, this is called a floating point data type, and whenever Python does division, it's going to return a floating point value as opposed to giving you an integer value. Now the next question might be a little bit different. We need to calculate the log base 10 of 400, and there's no function inside of Python that can calculate logs. Log base 10, natural log, doesn't matter, cannot do it. So what do we have to do? I'm going to show you the solution right here. I'm going to say code, and I'm going to say import math. Import math. Now we did not have to say pip install math. What actually happens, there's a couple of packages that come pre-installed with Python. You still have to insert them into your currently active environment. So I cannot use any of the functionality inside of this package until I've imported it, but you don't have to install it. That's one of those packages that come pre-packaged with Python, although it's not visible unless you import it here. So we hold down Shift and return, and now all the functionality in the math module has been added, or now at least I have access to that. So if I want to say calculate the log base 10 of 400, let's see the code that was written. It says math.log10. Now that log10 is a function. I know that it's a function because open close parentheses immediately following that. And there's an argument inside of the parentheses. This time the argument's 400. The log function knows what to do. You have to give it an argument. That's the information that it's going to use to do its job. And its job is to calculate the log base 10. But it is not available in Python. It sits inside of this math package. So to find it, for Python to find it, you have to say math.log10 to be able to find that. Let's execute that, Shift Enter, Shift Return, and we see it's about 2.6. Now there's another way to go about this. I'll just show you that as well. I'm going to say code. I'm going to say from math, import, and I'm going to say log 10. Now, so many of the mathematical functions are inside of this package. So I'm just going to run that. Now this function log10 has been added to the currently active namespace. That's what we say. Namespace means all the stuff that Python can do currently. We've just added log10 to that. So I no longer have to say math.log10. I can just do log10 directly as if it's part of normal Python. So let's just have a look at that. I'm just going to now say log10 of 400, and if I execute that, I'm going to get exactly the same solution. So this is what I want you to do. So I want a nice, neat Jupyter notebook, and I'm enforcing this because this is what a modern research document looks like. We want the ability not just to have lines of text as in an old-fashioned script file. Certainly you can do that. If that's what your job requires, please do that. But for modern reproducible research, you want a research document that shows all the steps of your data analysis, and you have the ability to share this with people who don't necessarily understand biostats and does not necessarily understand code, but you still want to share that with them. They are domain experts in their field, they've joined your research group, and you want to share your analysis with them. A Jupyter Notebook allows you to add normal text, images, sounds, all sorts of things that you can add to a Jupyter Notebook together with a code, and we can all see the code, we can all see the analysis of that code.